This is exercise D, question 26. For Z has a modulus Z minus 4 plus 2I equals to 2. As we know, this is a locus of circle, center at 4 plus 3I. So this is a circle, center at 4 plus 3I. So let me see, 1, 2, 3, 4. Then 1, 2, 3. 1, 2, 3, 4. Yeah, this is 1, 2, 3. Okay, so center at 4 plus 3I, and then the radius is 2. If the radius is 2, on the left, it should be at 2, 3, because the radius 2. On the right, we're also passing 6, 3. The minimum point, the lowest point is 4, 1. The maximum point should be 4, 5. Okay, so we have a circle like this. Right. Okay, now what is the minimum possible point for imaginary Z? That means we need to find out the lowest sorry. This is very annoying when I try to write. So the part A, okay, I can only write here, that means. Okay, so part A asks about the minimum of y coordinate. Okay, so that is 1. That's why the minimum of imaginary part is 1. The part B asks for the maximum of the real part. That is the one on the right, so it is 6. Okay, now the difficult part is C to F. What is the maximum possible value of modulus Z? So basically part C asks for a point that is a Z value, has the largest distance from the origin. Now, as we can tell, if there exists such a point, it must be start from origin, passing the center. Okay, so that is the one with the largest distance. And that distance is the distance from origin to the center. So it's the square root of 4 squared plus 3 squared, and then plus another radius. So that is 5 plus 2, and that is 7. Okay, so from the origin to the center, 5. From the center to this part, 2. 5 plus 2, 7. Okay, part D, the minimum possible value for Z. Now, if it's the minimum, it should be the one with the smallest distance. Okay, from the origin, and that should be here. So that should be, this time is the distance from the origin to the center minus the radius. Okay, which is this part. Okay, smallest distance. Okay, E. Find the minimum possible value of argument Z, giving your answer in radians correct to 2 decimal places. The other one is finding the maximum possible value of argument Z, giving your answer in radians. Okay, now let's look at this one now. Where is the minimum argument? The minimum argument should be a line from the origin touching the circle. Okay, let's say it touched the circle at a point here. So this part is the minimum angle. This is the minimum of argument Z. Okay, let's call it alpha. Okay, because it's too small to write, let's call this alpha. And then, according to the geometry, circular geometry, this one from the center, if I draw a radius, that radius should be perpendicular to a tangent. Okay, so here we have formed a right triangle. Now, if I copy this to here, basically you have if this is the tangent, and this is alpha, okay, so as you can tell that this alpha is equal to the bigger angle, let's call it beta, minus the small angle, let's call it theta. Okay, so alpha is equal to beta minus theta. Now, how do we get beta? Now, beta facing this part, and this part is the y coordinate of the center, and that is 3. And then the adjacent is 4, so beta is tangent inverse 3/4. When you come to theta, as you can tell, the theta having a radius 2 opposite the angle, and then also have the 5 as the hypotenuse. Okay, this is for the right triangle of theta. So opposite over hypotenuse, that's a sine value. That's why theta is sine inverse 2/5. So tangent inverse 3/4 minus sine inverse 2/5 should give us the smallest value of argument. Okay, the last one asks for the maximum value of the argument. Where is the maximum value of argument? It's supposed to be here. And then you may realize we have this triangle that is congruent. That means exactly same as the other triangle. So basically, the largest argument is something like the theta plus the theta plus the alpha. Okay, so this is the largest one. So it's a tangent inverse 3/4 plus sine inverse 2/5. Okay, so let me explain again now. Tangent inverse 3/4 is already theta plus alpha. and then plus another sine inverse 2 over 5, which is another theta. Okay, so this gives us the maximum argument. So this is how we do the question 26.